Okay, so we have Adam here. Excellent. So I
Hi.
could have given more time to Nuha, but then it means that the next two presenters then are going to be back to the strict time, and that wouldn't be fair. So we have now Adam Timlett, and he is going to tell us about the challenges on can MDE help those in business and science to understand and investigate interactions in their domain with the periphery. It's all yours,
Yeah,
Adam.
thank you, Nelly. Yeah. So I work in industry rather than as an academic, although I do some independent research just for a bit of context. And kind of the research that I'm doing at the moment, I think presents an interesting challenge to people who in the MDE community potentially. So I'm going to talk about the challenge that I want to propose for people in the MDE community to maybe try and solve. Um, and the challenge is about uh, being able to understand the interactions with different domains, with the periphery of those domains, and what the value of that is. So I'll try and explain what the solution is and the problem is, rather, how why it'd be good to solve it. So um, yeah, so there's this quote from Leonard Cohen. I don't know if you're aware of it. It's from a Leonard Cohen song. There's a crack in everything, and that's how the light gets in. And that's kind of related to the idea that you'll see in the kind of the research about how where do new things come from, and that new things come from the gaps in terms of what we're already doing. So, oh, I should also say this artwork is by my friend James Robert White, who's an artist who he creates art in the area of kind of complexity. So he kind of creates these paintings, which is in one example of this painting. Um, so first of all, let's talk about domains, and we need to understand that domains are really a human invention. So human defined domains are closely associated with human agency. What we're interested in doing, what we're trying to achieve, and also how we specialize in terms of what we're doing and say this is my job and that's your job. And so the boundaries of domains are set up by the needs of the agents who demarcate those boundaries. Um, Now, a simple example of domains is obviously the internet, where we have, you know, uh, domains defined by the naming conventions. Another example is obviously is credit card numbers. Um, it's a simple way of efficiently doing work, but you can see that if there's a credit card number with a stem that belongs to one bank or is assigned to one bank, then it can just issue cards without having to worry about anyone else having the same card number on a different bank. It's a very, very simple and effective solution that we use when we're managing data in IT to create domains where there's no overlap. Um, and obviously, we have other domains. This is my company's domain name, ppluk.com. Um, in my industry, we have international performer numbers, just to kind of labor the point a bit, but these also have stems for different countries, so we don't overlap. In reality, however, many real phenomena do naturally overlap, and uh, they're natural domains rather than human domains. So they're not determined by human agency. They just are how they are. Um, so why does this matter? This difference between human domains and natural domains. Um, we have domains like in academic research, uh, such as biology or subatomic physics or cosmology. Um, and in reality, the domains of the academic research are not demarcated in nature so clearly, right? So we think of these as natural domains, but they're still human domains. They're still motivated by human agency to do research and say this is my area and my boundaries of my research area. Um, and so, because those are not really natural boundaries, we miss the potential for discovery and opportunities to collaborate if we are too strongly focused on the human defined aspect of that domain. And so the need for collaboration is obviously very important, and is also getting more difficult because human defined domains of research are getting more and more specialized. Here's an example of a very niche methodology I was learning about from a friend: protein X-ray free electron laser crystallography. So just an example of a very complex, relatively new method which exists, and obviously people have to be an expert in that method, and then it's a very specialized domain, and this is just happens more and more as technology gets more complex. So the challenge is to detect where different domains actually overlap and coalesce in the same area, even though the agent that created that domain wouldn't otherwise be aware of it. So this matters for discovery because almost by definition, things that are really new fall outside of the recognized domains of a researcher or business. Even if you're thinking of innovation in terms of the daily function of a business. Obviously, there are many examples of this. One is the cosmic microwave background, which was discovered by an experiment which had no intention of measuring this, and was just trying to remove noise that couldn't be removed from the telescope when the cosmic microwave background was then discovered. And so the natural domain just crossed into the experiment that was designed, and the people who designed that experiment were lucky enough to eventually realize that and make this incredibly important discovery about the echo of the Big Bang. So with business domains, you have things like online shopping business Ocado they're a grocery business, they're online, but now they're mainly an automation technology business because the needs of the business changed actually what their daily function was into something else, and that's because the opportunity crossed into where they happen to be, and so they were able to take that opportunity. Another reason to look at this notion of natural domain overlap is efficiency. Other people have been talking yesterday about interoperability of data, so being able to combine data from different studies in a way that adds to the power of the data statistically to measure things. I saw an example with CERN gathering data from different experiments and combining them together. Or in the case of business, small tweaks to data collection can then be useful to a different function in the business than the one that's collecting the data. So if you're able to detect that potential to tweak what people are doing to make it more useful for other agents in other domains, then the efficiency of the process increases. And I actually started working in IT in academia with a study into molecular genetics in the late 1990s. And people used to hold on to their data and say, this is my data, you can't see it, I've spent all this money or got this research grant to collect it, and I'm going to publish results on it. Well, that's now changing. People nowadays are publishing their data online, they're publishing it to be used. There's huge amounts of data, but are they collecting the right data? With small tweaks, they might have been able to make the data they're collecting more useful for people doing things they didn't even think of. And I'm going to give some examples of that next. So here are some examples of some desirable outcomes. So an example I came across in physics is a telescope, not this one, this is the James Webb telescope, but a different telescope, an Earth-based telescope, I guess was used for a deep space survey for mapping dark matter. But the data that was collected for that deep space survey turned out to have the capacity to be utilized by other researchers who are researching comets in our own solar system by comparing the delta of where the survey crossed over the same piece of sky and something's moving between the two different times that the picture was taken of the same patch. They could detect comets. But obviously the original research was nothing to do with comets at all. But why couldn't that potential be actually detected when somebody registers the model for the data to be collected? In biology, there's some fascinating research that I can see on Twitter. I've posted an image here of an example of people doing physics research in kind of microbiology. So looking at, how being able to model the dynamics of cell structures can reveal the physical properties that have also evolved for those cells. And biologists would have no idea, or to think, to look at the physical properties of the cells in terms of their ability to damp forces of acceleration, for example, which is what this study is about. And then in business, you find that people collect data for operations, for their standard operations, but they could be used for completely different purposes analytically, for their organization to be more intelligent in ways that the people at the operations side collecting that data wouldn't have thought of. So in terms of how this relates to my research, I'll just briefly explain this. Some useful representations to kind of like consider when you think about this idea of what I'm calling natural domain model driven engineering. I mean, I'm not sure if that's a real term. I've just come up with it. But useful representations that I have thought about a lot is the idea that human agency involve domains where a coordination demand, so the demand to kind of coordinate with the environment or with some objective, is represented by an agent that ensures that that demand is met. But in the environment, if we think of natural opportunities and natural domains, we often find coordination demands that are not represented by any agent. And that's kind of what we're interested in here, is those unrepresented things. And the periphery can be thought of this kind of agentless element where no agent is responsible for looking out for that opportunity or that coordination demand that's actually there. So I'm writing a book on this concept of agentless agency and how coordination is often achieved with coordination demands that are agentless, and how that works. And a very important example is natural selection, because Darwin observed the human breeders selecting dogs to be bred, domestic varieties of animals, and how humans could adapt those breeds through choice. And then he realized this could be done without any agency. This could be done naturally, if you like, in the natural domain by natural selection. So this idea of agentless agency is actually in Darwin's original idea. It's part of what's so interesting about the idea of natural selection. So I want to explore this idea and see where else it's a useful concept to actually help us to understand what happens and how opportunities arise. I'm experimenting with graph databases to represent these unrepresented coordination demands, and I'm looking at software project requirements, things like that, where agency of the coordination demands are not represented by agents. They're not in the original project requirements, and this relates to ideas to do with agility and so on. And so, just to wrap up, there's some relevant research by a researcher called Kenneth Stanley, an AI researcher, and Joel Lehman. They've written a book called Why Greatness Cannot Be Planned, The Myth of the Objective. And from my perspective, this is about agentless agency. That's how I would interpret that book. But it's a very nice book to read and think about. And I'm working on this paper on agentless agency, and I'm also working on a book about this topic. And I'd be really interested to see what people think about that. So thanks to these people for the conversations and discussions. And yeah, there's some reference ideas there. There's also a biologist called Andreas Wagner, who's written a book on the concept of innovability. And I found that very useful as well. So yeah, that's a bit of a whirlwind tour perhaps, but we can discuss it more.